But Victor and José come from Telefonica. I met Victor a long time ago when working in different projects. I'll be controlling your time from there. Thank you, Roman. Hello, everyone. My name is Victor Mundilla. I'm a product manager at 11 Paths. For those of you who don't know too much about this, I'm from the product side, although I am in charge of taking to the market ideas and methodologies that we use in our labs, and those methodologies that are used by our engineering teams. He's my colleague, José Torres. He works for one of our labs in Malaga. I'm an innovation analyst at the Innovation Lab in Malaga. In fact, I'm coordinating several technology projects that are still in place. The main purpose of this presentation is to tell you about the things we do in 11 Paths. We'll be using some practical examples. It's the first presentation after lunch, so we'll try to keep you awake anyway. There's no surprise if I say that mobile phones have changed everything in our environment. They've changed the way we communicate, they've changed people. There's more than 2 billion mobile phones in the world today, with more than 190 billion applications downloaded every year. That is quite a lot in terms of retail market revenues. So attackers obviously focus on those areas of business which are profitable. At the end of the day, we're talking about more than 5 million new applications every year. 9,000 of those uploaded daily. Most of them are legitimate, but a lot of them have vulnerable versions. Some can circumvent the security methods that Google and Apple have in place to inject Trojans, adware and ransomware. So attackers need to make an effort. And in order to minimize the amount of work they need to carry out, they have their own industrial processes in place. These applications are developing so fast, evolve so fast that obviously all of them have bugs and flaws in their design. Many of these applications, the ones that are legitimate, also contain bugs and vulnerabilities. We need to be able to protect them. We need to ensure that these applications are free of vulnerabilities in order to avoid other stakeholders from attacking them and attacking the end users through those applications. These are some examples of recent incidents where bugs were found. For example, in Instagram, data was leaked for certain celebrities. This is something that could have been combined with a social engineering attack in order to get hold of credentials in a massive way. This affected a singer, Selena Gomez, who is now with Justin Bieber, and that might have had an impact, a serious impact on her privacy. We at 11 Paths are devoted to creating tools and creating processes which make life as difficult as possible for attackers to do their job. We analyze networks, we analyze connections, we analyze advertisers, we analyze all sorts of things. And as I said at the beginning, we'll show you some examples of the work we do. I'll show you some videos. I meant to do this online, but I'm afraid I will have to use these videos. This is our tacit platform. This is where we have downloaded 10 million applications so far. I'll show you the analysis that we have carried out. First of all, we have created a platform, let me explain what this is all about, that allows us to do searches on applications based on certain criteria. In this case, we've searched by title, but you can use other criteria for the search. You can search on the email address of the developer, the name, the description, the number of classes used, the name of those classes, and that allows us to detect all those applications that pretend to be legitimate and created by us to start with. We also developed an analyzing tool for static vulnerabilities. I think the video was moving too far, sorry. So as I say, an analyzer to detect static vulnerabilities. In this example, we're trying to detect a malpractice, which is quite common, which is hard coding certain elements within the application itself. We have developed a grammar that allows us to do a search based on these parameters that you see on the screen. Search for something that meets all of these requirements. This is what we do, and that gives us a list. We click on one of them. Here we have detected that there is an application which has its own IPs. I'm not sure you can read it from the back. I'm sorry about this. I'm not a Mac user myself. So these IPs are internal, but can be administrated for the website itself. We can do other types of searches. I'm sorry about the video. This is an internal IP address. This could be an internal administration IP address. And so this information shouldn't be visible through the application. This analyzer allows us to detect applications which have not been programmed properly and which may be displaying sensitive information through HTTP. Here we see that the user ID and the passwords are hard-coded and are sent unencoded. Here we see that the application has its own internal IP addresses, but it is sending those credentials, the user ID and the password, using HTTP in the open. These are poor practices, poor security practices that should be avoided at all costs. And this is precisely what we aim at detecting. You know, we need to ensure that these bugs are not present. But it is not just about information leakage. We could see a certificate leak. Application was. This is the place where the credentials are stored. This is a VPN client, and this is probably where you stored all the credentials to connect. Take it easy, don't worry. In this case, we have detected another one where you have a .key file. It has been encoded, but it is the private key for a certificate. Is it necessary to have that information within the application? Well, we don't think so. We've also set up a vulnerability search engine that allows us to detect serious vulnerabilities or slight vulnerabilities. And we have analyzed 10 million applications. After the static analysis, we have detected vulnerabilities in 80 million applications. In some cases, these are quite severe vulnerabilities that allow any potential attackers to extract information or details that could compromise the company, the application, or the users. Just to give you some facts and figures, around 15% of all applications are in a critical state. This is a breakdown of all those applications that are in a critical condition. There are some industries, like the finance industry and the healthcare industry, which are especially affected by this type of applications with critical vulnerabilities. Some more facts and figures on the type of vulnerabilities that we have identified. In some cases, they have to do with what we call the quality of the code. This is poor practices when coding. Things are exported to Android components. Permissions are requested where they are not necessary. So information which is not really necessary and which is requested, that could have an impact. And in fact, some of these applications are so poorly coded that they might be detected as malware. Amongst some of the most remarkable vulnerabilities that we have been able to detect, we have critical items that have to do with data storage and privacy. We've also seen that there are many non-secured communication channels between applications and the back end. But above all, there's a lot of self-signed certificates. The problem with self-signed certificates is that if you lose the private key for that application, you lose control altogether. You will not be able to generate updates or anything like that. Another thing we've seen quite often has to do with XSS vulnerabilities. Applications can be installed using older versions. So you might be adhering to best practices, but since you're able to install older versions of certain applications, you will be in danger. Another thing is dynamic code loading. Your application has to rely on external code that comes from other external applications. This is what droppers use. This is an application that installs legitimately, but then it does establish a connection to a dodgy website. It installs a payload, and the malware is installed using that method. You really need to be sure about the need to have dynamic code loading. And then we have inappropriate use of platforms. Sometimes the user may enable the backup mode for their applications, and that leads to a potential extraction of confidential information, credentials, certificates, and it would allow the malware to export components. Any data that the application uses in your phone could be accessed by other applications installed in the same handset. So if you're connecting to the internet using your own data, that data could be uploaded to a server through another application in your phone. Another video on how to find suspicious applications. Going back into our search engine, the first thing we do is a basic search for applications. There are certain applications that are called flashlight, and they don't have a permission to use the flashlight from the smartphone, so that obviously is suspicious. If you cannot use it as a flashlight, obviously that application is not legitimate. Let me go back here. I see that it can access the internet, it can access the camera, but it doesn't really make any sense. It cannot access the flash, the LED flashing light. And then there are other things that get more sophisticated. This is the cloak and dagger type of incident applying to Android versions. Here we have an application layer, and anything you click on the screen is collected by the application, is captured by the information. These are some examples about this type of attack. So here we see that the attacker overlays a grid on your screen, an invisible grid, of course, capturing whatever you point at on the screen. In order to detect this, we can launch a query to see what result is returned.
Funcionalidades que nos permitan hacer esto. Entonces, para ello ponemos esta consulta en la cual
So we run a query here, and we tell the system that we're looking for applications that have permission to do this. System alert window. In this case, we've refined the search down. We've narrowed down the search to applications that have permissions to send text messages. If you have an application that can get tokens using text messages, and the application is buggy, you could be attacked. This is the icon for a crossed out cloud. That means that these applications have been withdrawn from the market. They've been detected as suspicious or unsafe, and they're no longer available. But obviously we have copies of those applications in order to simulate attacks on them. Here we see we have lots of permissions. The application can access the system alert windows, capture text messages, receive text messages, and several other permissions that don't really make any sense for an application of this sort. The results of our analysis, by the way, are published in our blog at 11 Paths. And that takes me to the next section in my presentation. This is another category of analysis that we also include in our services. We have handsets that can cost up to 1,000 euros or even more. People are paying 1,000 euros for their handset, and yet they want to use dodgy applications in order to avoid paying 5 euros for the legitimate ones. So they keep using Google to find the APK binary. Obviously, if you buy the legitimate application through Google Market, you will have the security layer implemented. If you go for the fake ones, you won't, in most cases. In this example, we were looking for this application, Android APK World. This is one of the main sources for malware in mobile phones. So here we have the website that allows you to download an illegal copy of that application. So we do that, we download the application and we analyze it. The main purpose of this application is not to give you a free version of the legitimate game. Far from it. This application has its own purpose, which is monetizing the effort the developers have made getting money through the vulnerabilities in your telephone. In this case, once we have downloaded the application, well, you know, the Android applications have this format. This is the application itself, and an Android manifest.xml, which is the part establishing the permissions that are needed for the application to be executed.
Hacemos un ojo.
So if we take a look at the app and the permissions of that app, we would do that through a tool XML APK, and here we see that this app, because of these permissions, looks quite complicated because the permissions are quite elevated. It says receives boots complete and power on. It means that once it is on, the mobile, and also once the mobile phone is blocked. And then we'll do now a process that we often do automatically, but we will do that manually. Now we will look at the first class which is being run, which is main activity, and then we will be using text to hard utility that will help us transform that class into this other format so that we can make a more detailed analysis about the intention or the target of this app. We use these tools. Okay, we generate this jar file, takes some time. And once we have the .jar file, we open the Java compiler, and then we browse through the different classes of that package. So if we open this file, we see a number of classes. We go to WP Legal Marvel Hub, and that is what we will be running to see the type of browsing that is made. So we have this class here. Well, this is very poorly seen. So the name is site name activity. Okay, that is a typo, that is a mistake made by the Android developer. So instead of site main activity, it says main activity. So it means that we could look up that error to find the apps that have that class name. So therefore, we would be able to make an attribution coming from, we will make attribution to other apps coming from the same source. If we analyze the app, we see that there are a number of classes with kind of a denominator, the coins, the currency, When you register, they give you an APK and you can insert as a kind of advertising in your apps. So therefore, if you infect browsers or mobile apps, in this case, what you do, or these apps will do the mining for you, and they will get currency. And web advertising is generating less and less revenue, whereas cryptocurrencies are generating higher revenues. So attackers use these type of things to carry out their attacks. So if we take a look at service now, let us take a look at the AP kin, which is being used in this case by the attacker to monetize his attack. So this is the APK which is being used for this mining activity. All right, so now, okay, we will run that in an Android emulator, and once we start the app that we downloaded before, we can see that CPU is at 30% now. The moment we started, mining starts, and then we will also have like pop-up messages with advertising to download the premium products. So it is mining, and you can say, well, no problem, what is this app doing? Well, the app is doing absolutely nothing, but we see how the CPU is significantly going up. So in this case, you go and say, well, this application is not running, it's not working, it is doing nothing at all for me. But actually, this has started a service behind it. And this service will be doing mining in the background, even if the app is not started. So that's the way the attacker is persistent. So that would be for an app. So we've done that manually, but in this market, and we have hundreds of apps. Downloading them all could be tedious. And even if we were to do that with a cool or with any other crawling program, many of these apps come with JavaScript, which is interpreted through Q or wget. If you do that, you will not be getting the hyperlinks. We may use tacit, that's what we use at 11 paths, but you could do two things. One, to click on each of the hyperlinks, which is quite tedious. I don't recommend you do that. Or you could also do like a Homer bird, that is to say, someone doing click on your behalf or doing that click for you and downloading the apps for you. How am I going to do this Homer, to use this Homer bird? Well, we have an app department for apps, and then we do that through a Selenium tool and through XPath. So they all have a label of XPath. If we open up Chrome and we click on it, we can see, we know that this link is this call to action, and this is class of JavaScript. Oh, sorry, this is driving me crazy. Okay, this Mac is driving me crazy. As I was saying, XPath, you get the link to click on it, and then you make a script in Python to open up the Chrome with the Selenium controller. It will look for the call to action, and it will say click, click, click. And then in a kind of a handcraft manner, or if the site is complicated, meaning that it has JavaScript, this is what facilitates the download. So we do Well, if we want to see it live, wait and see how simple it is. Okay, this starts a website and automatically it logs on and downloads it. As I say, you can do it like this, in this way, or if you go to test it, you could do it in a more simpler manner. So in the previous app, we could go back to it and say, give me all the apps that are signed with the same certificate. Or in this case, we've also seen a class which is site mine as activity, and we could go and say, well, give me all the apps that belong to the class site app as activity, and this would allow us to identify the same mistake. Changing the certificate is simple, but when it comes to changing the application, that would require changing the full code. So this is the way we use to identify malware with the internet tools available to us. And now I'd like to give the floor to my colleague José. This is one of the things, the analysis activities that we do at 11th Paths, and we do it not only to analyze suspicious patterns, malware, and or vulnerabilities, but we also would like to share with you an analysis carried out by my colleague about ad networks. All right, so thank you very much. At our lab, same as when we conceptualized Tacit, we just really wanted to see what happened with the market, with mobile apps, and we wanted to have an overall view of that. At this point in time, at the lab, we are trying to analyze to see what is happening with advertising in mobile apps. Well, you all know this, that whenever a developer wants to monetize his app, he's got several options available to him. The first one, or the most conventional one, is advertising. But crypto mining is taking away quite a lot of share nowadays. Then we also have other means which are not that legal, which is the selling of data and subscription or registration to premium services. So often when we want to monetize our app, whether it is legit, illegit, or a-legit, so with a-legit we mean spam or something aggressive for the user. In both cases, we resort to an ad network, which is a company that delivers on-demand advertising. Then you give some space to that agency, and the agency delivers the ads for you. What do attackers do when they want to monetize their apps? Well, they either produce or build their own apps, or they just resort to the technique of repackaging. They use an app which is popular, they repackage it, and they publish it and set their own advertising. As well, Victor mentioned before, you never know what you are downloading when you download an app from the internet. So these type of apps that have been repackaged by attackers often come with highly aggressive advertising, who is well paid, very well paid. They are not looking for user experience, they are looking for a number of clicks and a few minutes of video streaming. So we use these 10 million apps. We try and detect whether they came with advertising or not. We realized that over 4.1 million apps had advertising, which is quite a high number. And the next question is, how are they used? They have embedded advertising, but what type of advertising? What way? How much advertising? Very quickly, I will describe the research study that we carried out. First of all, we wanted to take a look at the ad networks out there. So in the beginning, we selected some 40 ad networks, which is quite a high number. In the second iteration, we could see that there was a good number of catalogs out there. However, the market share was taken up by the 12 top ones. Okay, so therefore we decided to select those 12 top, and then we carried out a detailed analysis of SDKs, which are libraries provided to you by advertising managers so that you import them into your development and so that you can insert advertising or embed advertising in a simple manner. When we studied SDKs by using Tacit, we could see whether an app came in with ad networks or not. And as I was saying, we were also interested in finding out about the use that was being made of the ad network. Last, we wanted to see whether we could translate that into an app, because users want to see the type of advertising that came in with a specific app. The first thing that we did was just to detect presence of ad networks. We could do a static analysis through the engine that Victor shared with you before. The first thing that we did was to take into account, was to take a look at the activity that was being used. This allowed us to cover for most of the ad networks and to find out about the presence of it. So having an ad network does not mean that you will be launching it. So the second criterion that we used was analysis of the code. We took a look at we analyzed the type of classes, the name of the classes. So we could see that it called methods, and then that it also embedded different SKG classes. It was very tedious to go through all the SDKs provided by each of the ad networks and the different versions of them. And then last, we double-checked the permissions. Using a set of permissions does not entail that you use a specific SDK, but if the SDK requires a couple of permissions, if you don't have those permissions, the advertising will not be launched. This is kind of a double check. So what is the information that we got as a result of this study? Well, first of all, I wanted just to check which was the usual or the standard number of SDKs. So we could see that that number, the most common number, was 2. Well, some SDKs pay you more for videos, others pay you more for banner. So most people have a main one and a backup one. Actually, what we find suspicious are those apps that have 4 or more than 4 SDKs. So when we studied these 10 million apps, we could see that over 500 of them had 15 or more SDKs. So highly suspicious. As a result of this study, we developed a tool that uses the database of traffic, enabling us to make queries real time. So once we had all those apps and once we could see which app used the SDK for them all, we produced a number of metrics to find out about the use being made of an SDK and also to assess the soundness of the apps. So let me explain this graph. This is about the total number of apps that use at network, the number or mean downloads of those apps, the percent of those apps that are dead, that have been killed by Google, and then the mean days alive before death, an average of 51 days. A potentially malicious app will pass a notice for an average of 50 days. So curious case is Facebook, largest market share. So Fiverr, it is the least used. I hope that there is no one from Fiverr here. However, Fiverr is topping the list in terms of average downloads. So this may take you to think that people upload apps that are downloaded through a number of mechanisms. And then when we analyze Fiverr in detail, we could also see that it was also the lowest in terms of apps dead. Also the mean number of AV, it's also quite low in the rank. In terms of average rating, this is the best values. I'm not going to make any advertising, but in principle, Fiverr looks sound. So this also tells us about the healthiness of SDK, also tells us about the level of security of it. We also wanted to find out how invasive that SDK was. For that, we have this option giving us this type of information. So we download the advertising and we can see the average consumption in megabytes, mean consumption in megabytes, and direct impact on your wallets. For each of the apps detected for a network, we just did an automatic listing or catalog in 5 levels. So number 1 are the most invasive apps. They open up browsers, open up videos that you cannot eliminate, and based on that, we made a ranking. So this one has a lot from group 1, group 2. This is all in all negative assessments, negative results. Fiverr comes out better because it uses type 4 advertising, which is banner type advertising. And as I was said before, we just really want to see what happens with an app when you download it. I will download a couple of apps. I will be using them as examples. So this is a bit slow. So we also added additional information that may be relevant for the user, in this case the size and permissions. So I don't know what this app does for you, but it has permissions to access Wi-Fi network to network. Doesn't look suspicious. However, it uses one of the most invasive SDKs. It uses this startup. It consumes quite a lot of data, and here we see the type of ad types that have been detected. And I have another example here. This is an app for advice for pet care, or tips for pet care. I also would like to mention that advertising is taken into account in the world of AVs, because some SDKs such as AirPush, if you scan an app with SDK, most AVs detect it as malware. So here we see the size, we see the permissions. So this app has 4 SDKs, that is to say apps from 4 different networks. A rating has been given to each of them. And from there, a rating is produced. So this is an interesting app, because when I ask for permission, this is what I found. So it uses this boot complete permission. This helps it detect that the system has been started. It also has a permission for wait log. It will keep the CPU alive in case the device gets blocked. And then we have duplicated. We can still use this. This allows the device to send in push notifications to the mobile phone. After seeing that, so considering the map of permission of this app, we could think that it does crypto mining as well as advertising. So nowadays there is kind of a war between advertising and ad blocks. So sometimes they resort to most difficult techniques or bad techniques. For instance, fax flus through DNSs. They change the name of domains so that advertising is not detected. And to finish off, we also made an automated ranking that allows us to trace the soundness or the health of each of the markets over time, so that we can see the tendency of users when it comes to using this type of markets. So we can see that some of them follow a positive trend, for instance, such in the case of fever. So this allows us to trace the workings of them. Alright, so this presentation is intended as showing that applications should not be looked at from a single vector. That is to say, only vulnerability, or whether it is malware or not, whether it is suspicious or not, and in this case, whether you are taking advantage of advertising or not. So we just want to take a look at it from an overall viewpoint. And we at 11 Path, through a single source, we can produce, or we can make different types of analysis. So, and I hope that you like this presentation. We are always looking for talents at 11 Paths, especially rooted participants. And as I say, we would like you to belong to our small family. I hope that you like this presentation. Alright, because we are a bit pressed for time, and I am to blame for that, not the speakers, we will take a question. One question. Well, if there are no questions, we move on. Thank you.